Ladies and gentlemen, welcome back to another video. Alright, so this is a new live stream, and this time it's actually in the day instead of the night. I actually haven't slept yet, that's why. But anyways, the aura didn't sleep this time. I'm still like, a vampire, but yeah, anyways. Alright, so let's see what we got today. Okay, so first of all, you can join my Discord server. You can find it in the description below so you can get notified when new streams, etc, etc. So everyone, live. Alrighty, so in today's video, or in today's live stream, we're gonna go ahead together and try to learn some Skia and Yoga with libraries with C++ and CMake. Modern CMake, obviously. So yeah, okay, and we'll see how that goes. Pretty much. Let me just verify because I'm just using my Wi-Fi. Seems so good so far. Cool. Alright, so let's just pop out the chat. And today we got the camera. That's cool. Okay, sick. Alright, so first of all, let's just check out one repo that some guy have. Yeah, Theo Paris, our admin, pretty much. Okay, so you can take a look at this later. We're just messing around with libraries. Okay, checking it out live. Alright, let's see. You can take a look. Okay, sure. By the way, if you guys have any projects that you want me to showcase on my live streams, please let me know. Okay, well, I didn't sign up. I forgot about that. Anyways, because I just reset my system. Alright, so apparently what this is a Skia experiment with Basil and Skia. I got it. Wait. Yeah, with Lix. So he's using libxcb, Skia and Dawn. So Dawn is like the C++ WGPU kind of that is used by Chromium, which is actually quite interesting. Dawn. I actually forgot about Dawn completely, to be honest with you. Yeah. I mean, it's like we're gonna need the backend for Skia, and honestly, I'm not sure yet which backend I'm gonna go with. Probably Vulkan, but now that I remember Dawn, it might change things a bit. But yeah, and libxcb. So basically, instead of using SDL3 or GLW, they're using XCB, which is like the X11, or you could say modern X11 kind of library, to basically create a window, get input, etc. for obviously for X11 only for Linux systems. But yeah. And alright, so is the stream going fine? Yep, seems great. Cool. Alright, so we got a Basil. I have never tried Basil, to be honest with you. But anyways, let's see the main.cc. I'm not sure why he's used this cc here. I mean, is this C++? Let's see. So he's using Graphite Dawn. Okay. Web GPU, right? Powers backend. Alright, so if there's no arguments, he's using Vulkan, I think, or what is that? Alright, and depending on the argument, he's just selecting some particular backend, apparently. Cool. Make demo status bar model backend app.run. By the way, if you're not okay with the AI like assistance, using AI, then you could just go out of this live stream, because I'll be using it probably in this live stream. So yeah, just a heads up so I don't waste your time, pretty much, because there's a lot of polarity when it comes to AI nowadays, so I just don't really bother. But yeah, demo graphite dawn xcb app options, return app.run model canvas. Okay, so here we go, Skia. So Skia canvas. Alright, size and demo UI, draw status bar, canvas size model. Alright, so that was the main CC, and now we got also the graphite dawn xcb app. Alright, so this is quite big, huh? SK surface, dawn native. Okay, so he's not using the regular dawn, he's using the native part of it. Cool. Right, using clock, event mask. Oh yeah, XCB. Oh crap, I've not used XCB for quite a long time now. I actually made one tutorial. I think it's probably the only tutorial on YouTube for XCB, and people really liked it. But yeah, backhand matches selection, surface status to string, blah blah blah. Anyways, the XCB atoms interns. Yeah, I see. Change property, configure window. Yeah, honestly, like if you try to make a window using Wayland, you're gonna go crazy. So at least if you really want to go native, probably your best bet is just XCB if you don't want to use like a library. But yeah, big surface format. So here he's creating a window, creating the window surface, and then the device in the context, then he's configuring the surface. Cool. Move resize window. Okay, so this is like the frame loop. While not, should exit. Drain the events, move resize window, configure the surface, and yeah. And he's trying to render a frame here. And for rendering a frame, you get a surface texture. Theo Paris, welcome to live stream. So the owner or the writer of this code, status bar UI.cc is where I actually use Skia to render status bar. I forgot Yoga even existed. I guess that would have made it cleaner. I don't actually have that much experience yet with Yoga. And for Skia, I haven't touched it yet. I just got it to build off camera, that's all. So this is going to be completely live. I've never tried Skia before. But we'll see about it. Should be pretty simple, I think. But yeah, status outdated. Then we configure the surface. Right. Wrap the backhand texture. Draw the frame. Yeah, we might actually try to use Dawn backend with Skia, to be honest, because what I had in my mind was Vulkan, but it's just because I forgot about Dawn even existing. But yeah, get connection. Yeah, kind of I get some nostalgia looking at the XCB code. Yeah, because like when I tried to make my own XCB window, and like Wayland wasn't really that mainstream at that point, so I couldn't find that much resources on the internet, so I just had to kind of figure it out myself. And then after I did, I just made a video about it, and people loved it from the Linux community. But yeah. Hello, Comported Box, MPG, welcome back. Hey, I did wait for the face reveal. Oh, well, it's not the first time that I reveal my face, but yeah. Alright, set atom property, move resize window. XCB map window. So instead of saying show window, they just say map window. Go figure. Anyways, XCB flush, create the surface. Yeah, I think we'll definitely use Dawn as the backend. So that would be cool. That would be interesting. I haven't used Dawn 2 for a long time now. Right. Because like both Dawn and Skia are both used in Chromium. And like even Flutter used to use Skia, but now they actually have their own renderer right now called Impeller. They made it because back then they had problems with the first animation on mobile phone like lagging so hard because Skia was like, like compiling the shaders at runtime at the start of the application, and it lags out the user's phone until it did so. So they just made their own backend, and they actually had a lot of trouble with that for years. Like people were just complaining, the developers, the users, everywhere, like everyone, because they were struggling. In fact, they made it in Vulkan pretty much. But I think maybe they have improved by this point. But yeah, it's such an immense undertaking to create your own renderer and make it very well, whether 2D, 3D. So really, if you can afford to use a library, then just do. But it is always worth it to at least try once to do it by yourself from scratch. Yeah, I heard about Impeller. I haven't really used Flutter them. I haven't used Flutter neither, but their tech stack was interesting. And then you have Yoga library, which is like I'll also probably cover this in this live stream, which is like a layout engine by Meta that is used in React Native. So React Native, I actually had a wrong not opinion, but like impression about it. React Native, I thought it was just kind of like React. It's kind of like Electron, but just for phones. So I thought it was just like, Chromium embedded in phone, that's all, with JavaScript and React. But in fact, it's actually crazier than that. So like if you look into React Native, what it really is, they actually create their own engine that maps to the native iPhone or Android controls and like UI system, etc. And they made that using this Yoga library, which is very standalone. You could use it yourself too. That's the first one. The second one is for the JavaScript engine, I think they also made their own for the JavaScript engine. If I remember, it's called Hermes. Yeah, I think it's called Hermes. I couldn't get it to work, Hermes, last time I tried to build it, but who knows, we could try to build it too, why not? What else they use? Yeah, I think that's all for now. Anyways, so let's just go back and see. So this is the library, Yoga GitHub repo. There you go. So it's an embeddable layout engine targeting web center. So instead of having to go ahead and like create all the tedious layout calculations yourself, and it's probably going to be horrible and not even close to CSS and the modern standards for UI, you could just use this library. You could easily embed it. In fact, it's one of the most sane library to set up that is from a big company like Meta, or because like I noticed something with Meta, Google, and all these big companies, their repos, they're open source, but usually to get it to compile a lot of times it actually proves to be quite hard. Like but anyways, let's just keep going. So here he's creating the device, the backend, context, blah blah blah. Make recorder, figure the surface, drain the events, XCB stuff here, then the teardown. Make the instance. All right, so that's it for the Dawn XCB app. Now we go to, I think, the status bar UI. .h. Okay. Interesting. All right, so here where he's using Skia apparently. So local time string. Measure text. So we're getting the font and we're measuring some text here. That's cool. Default typeface. We draw some items. We get the canvas, the items. So here we're measuring the text, baseline. Draw rect. Make demo, status bar, model out left. Alright, so here we're clearing, then we have some pins, set NTL, set color, draw rect. Yeah, honestly, I don't really understand much from reading code. I like to write code. That's where I start to understand. That's why I kind of don't like using AI, like agents, to do everything for me. I like to write the code on my own, so I could actually understand it. But yeah. Alright, so yeah, alright, now let's just go ahead and see where we can go next now. Alright, so let's just open up a new project. Alright, so should we make it a library or an executable? I'd love to make like a library where like we basically include both yoga and Skia. Sure, why not? So okay, let's go with the latest C++, why not? I don't know what to call it. Let's go and call that, I guess, Kodo Kit. Fine. We're making the next Qt. Alright, so let's see. It's like, honestly, there's a huge gap in the ecosystem. Because like you either go full from scratch, you make everything yourself, if you want your own custom UI, or you go and use Qt, which is huge, right? And have a lot of historical baggage and going through a lot of changes, etc. But yeah, otherwise there's also MGUI obviously and other immediate mode UIs, but these aren't really meant for, you know, actual applications. They're just like for tools and stuff. But anyways, and obviously you also have Flutter and React Native, etc. And you know what's up with those two. But anyways, all right, enough talking for now. So let's see how we're gonna do this. Well, there's actually two ways that I found. I mean, obviously there's countless ways, I'm sure of that, but the main two ways is either using VC package or just using CMake and just doing it yourself. So if you want VC package, there is actually a port for that, and you could easily install it, and then you could just, you know, pick which features you want to use. But I'm not gonna go that way because I'm not sure which features they're including, etc., etc. So for example, here they're only seeming to include OpenGL for whichever reason. They don't have a feature for Vulkan, so maybe they don't actually support that. I don't know, maybe they removed it. So that's a red flag there. Anyways, but if you want to try to use it, then use it. It would work. So you would just add like the port Skia and it would just work. You don't have to do anything other than that. But because we're stupid, we're gonna do it ourselves. And let's see how that would work. In fact, the AI actually told us that there is a Vulkan feature, but as you've seen, there's no Vulkan feature there. Anyways, so what we're gonna use, again, if you want to do it on CMake, there's countless ways once again, but my favorite way so far seems to be just using Git submodules and like a super build. And we'll see how that works using external project thing. Honestly, I don't remember how the exact syntax is like, so we're going to be using a lot of AI too, at least as an assistance. But yeah, I think the latest Skia has a new graphite backend that uses bulk. Yeah, it does. That's what we're going to be trying to use. The old backend is called Ganesh. Yeah, Ganesh is like OpenGL and stuff. Yeah. All right, so let's see how we're going to do this. Well, first of all, let's initialize our GitHub repo, and let's say git branch -m main sick. Now let's just create a third-party directory. Let's go inside of that, and let's say git submodule add. So we're gonna basically copy the github.com google skia.git, which is basically just a mirror for their own to their own repo. As you can see, it's just mirrored, not really, because they don't keep their source code in GitHub. They keep it in their own kind of GitHub thing. But yeah, as you can see here, and these are like the commits, apparently the branches, the tags even. But anyways, all right, so let's go here and let's just say git submodule add, and it's going to take quite some time. Hopefully it wouldn't affect my live stream. Seems good so far, I think. Cool. Other than that, what we're going to do next is all right, so let's actually grab the documentation here. Or like just Skia documentation, right? Just documentation. All right, and where is the... So first of all, you got like how to download it, and you could use their depot tools. So you basically just git clone their depot tools, then you export that path, etc., and then you install their basilisk thing here, which would allow you to apparently regenerate parts of the build.bazel files instead of installing Bazel manually. Right, and then you also install Ninja, and Ninja you could get it from their G client, or with the bin/fetch Ninja. But we're not going to be using their depot tools, though you want to use them if you want to like make sure that you have the same versions that Google is using, so you wouldn't have any problems. So you might want to use this. Also, you need to use this if you're going to be trying to contribute to the repo, to Skia. So you do need this again, but for us we don't really need it. We're just gonna go with the GitHub submodule and we're done. And hello Federal, welcome to live stream. So clone the Skia repository. So yeah, this is what we're gonna be using. And as you can see here, you gotta go to Skia, and then you gotta basically say Python 3 tool/git sync dips and Python 3 bin fetch Ninja. Though we have Ninja in our system, so we don't need this, but we need this one right here. So what we're gonna do? Well, we could do it through CMake itself. First of all, we're gonna basically find, yeah, I think find package, probably Python 3. There you go. I'm not sure what's the difference between find Python and Python 3. I mean, good question actually. Hold on a second. It probably doesn't really even matter, but who cares? So what's the difference between CMake, find package Python, and find package Python 3? I think it's probably just the version, but we'll see. Why are you streaming in the corner of your room or a camping chair? It's a new home pretty much. It's the first time I stream in this place, right? So actually this is, what is it called in English? A refrigerator, right? Yeah. Specifically searches only for. Okay, so are two several modules designed to standardize how? Search only for Python 3. Okay, so Fight Python is just version agnostic. So obviously in here we want Python 3, so we're just gonna go with that. Find Python 3 and we're gonna make sure that it's required. So if the user of our repo, like let's say some contributor or someone who just wanna build our library, if they don't have Python, then CMake would error with you don't have Python. Please go ahead and go figure how to install Python. Next up, we're gonna add an executable, I think. And hello, Praise Village. Welcome to live stream. Hey, I'm new. What do I do to get into Google? I'm an aspiring full stack developer with a focus on backend. I'm not a Google engineer, so I can't really answer that question, to be honest. So yeah. All right. So add executable. Okay. Well, not add executable actually. Yeah, I think we need the execute process here, right? We need the execute process. And so what you give it here, you need to give it the command. There's also add custom command. You know what? Let's just formulate something with the AI really quickly here because the syntax gets hairy really quickly. So we're going to tell it to find package Python 3. Using modern CMake and use it to execute the command, not the command, like the what is it called? Where is it? Yeah, so to execute this essentially. Where is bro? Oh, there we go. To execute this, tools is inside of third party / Skia, right? Yeah. And what we're gonna do next? So yeah, let's start with this. And there you go. Components interpreter, not needed, but fine. Define the path to your script. So the sync script is CMake current source there, third party, Skia tools, get sync tips, cool. And execute the script using the execute process if you need it to run during the configuration stage. So the command Python 3 interpreter apparently, I was actually just going to like use the variable, but apparently there's actually a target for that. Interesting. And then the sync script. And then the working directory, and then the result variable. All right, and if not, sync result. So basically if it failed, then we're gonna say failed to execute get sync tips or dependencies. And then we're gonna give it the sync result that we got from the process there. All right, so let's just copy this and let's see. Whoops. If not sync result, yeah, that looks good. So if you just sync the CMake changes here, get sync dips, yeah. In tools, let's see, where is that? Where is tools? There you go. That's strange. Let's see what it's gonna say. It should work. Set a manual finding path. Yeah. I mean, hold on. My bad. Let's just, whoops, what did I do there? Let's just say ls in the third party tools. Yeah, Skia/tools. There you go. And we're gonna grep for the git sync dips. Yeah, it's there. So what the heck? Right. Maybe since we set the working directory to whichever this is. Actually, you should probably just set it to maybe tools. I don't know. Let's see. Oh, wait a second. Is it? No, it doesn't have an extension. What the heck? Could it be the working directory? You know what? I think we're just gonna do it manually for this one, at least for this part. Fine. I don't know what's wrong with that. I mean, it worked last time I tried it, but right now, I don't know. So let's just go ahead and say Python Skia/tools / get sync depths. And what this would basically do, it would go ahead and fetch all the external dependencies that it needs. I want you to basically kind of like make a, you know, self-contained CMake, so you don't have to do any extra steps yourself. But I don't know what the heck is going on there, and I didn't want to waste any more time on that. But this is how you do it manually. Enable to access the requested URL, returned error. Resource has been exhausted. Okay, so Google is already like metering me, huh? Interesting. So I think it's putting them inside of an external directory somewhere. But yeah, anyways, generate, or let's start a new chat. Generate CMake. What is it called? Yeah, external project for Skia. Compilation. You'll find gn inside of bin, inside of, well, third party /skia /bin, because basically after we ran, wait, what the heck? Thread failure detected. Really, that's weird. Maybe we could try to run it again, fine. As you can see, Skia is huge, have a lot of dependencies. It's apparently pulling in scripting, yeah, for the web build. We don't really need the web build, but it just basically pulls all the dependencies for you. I don't think you could change that. Alright, so I think right now it actually worked, possibly. So if you check out your bin right now, you could find like GN, their build system, essentially, kind of like Ninja. Well, not like exactly, but anyways, kind of like CMake actually, more of like CMake. Their meta build system, which we could use here. Alright, so generate CMake external project for Skia compilation. You find GN inside of third-party Skia bin. Yeah, go ahead, let's see. So obviously, first of all, we include external project. And let's just copy this first. And let's see what we got. So right here, we're gonna include external project, and then we have here external project add, Skia, prefix, binary there, Skia build. So here we're building inside of source itself. So basically, instead of having the build in a separate directory, we're just building inside of Skia repo itself, and that's required because like Skia kind of depends on those paths essentially. So that's needed. Configure handled by build. Okay, skip standard CMake installation config and no install command, and then the build command is Ninja. So out/release/Skia. The configure command adjust args as needed. So we use Skia source directory /bin/gn. Isn't there like a working there here by any chance? No? I mean, I think it does, but anyways, fine. So we're getting to the source code /bin/gn. We're generating to out/release, and then the args that we're given is official build equal to true, which is basically for building a release binary. But in our case, we don't want a release binary. We want to be able to, like, debug and go inside of the Skia library if we need so. So I'm gonna actually say false for this. Or you know what? Fine, just keep it for now. Is component build is equal to false, and after combination, you will need to link against the generate static library. Typically found in, I would say use add dependencies to add it, and I'm just gonna give it the whole kind of thing. Use add dependencies and make also a CMake target, wrapping the generated library. Yeah. Okay. All right, so just grab this part. This is better. So we're gonna remove this, and let's go. Right, seems good to me. So here we're adding a library, and also I'm gonna call this like Skia. I feel like, the quality of this generated is not like the usual, really. So you know what I'm gonna do? Let's try something really quickly. Yeah, so it was flashlight apparently. So let's just go with this one. And let's also add this part. Or let's see what it's gonna do if we go with flash. Because I really feel like the quality of the generated code is so damn there. Right, use font cache, define. Yeah, this is what sucks about AI. It's very not deterministic. Anyways, let's just work with what we have here. So fine, the add library and the add dependencies. Or you know what? Who cares? Let's just keep it as it is. Set target properties, import location, include, blah blah, and finally let's just link. So let's grab this here. And my main app is basically, in this case, CodeOKit. And we should be good to go. Let's just remove these comments. And this, and maybe we should be good to go. Let's remove this guy here. And yeah, let's try this out and see. And build. Right, so you shouldn't have these quotes here. And also another thing, to get you know, the build progress in your terminal, really, wait. You know what, let's go to the documentation really quickly here. And there you go. So you just say use this terminal build and then give it a boolean. And now watch this. Now we're getting the progress of building Skia. And as you can see, it works. So yeah. So what we're essentially doing here, so obviously this is just like the path, you know, stored in variables, nothing fancy here. Next up here, we're doing something interesting. Since Skia doesn't use CMake natively, what we do is we go ahead and tell CMake to go ahead and build this separately. And here you tell it what you're going to use to build it, the command that you're going to use. And in this case, it's our GN. So basically they're a meta build system. So we could configure the project, the Skia project. So we use the generate or gen subcommand. From there, we give it where we want to put the binaries. In this case, it's out/release. And then here we give it a few arguments, like is official build equal to true. And then we got the build command, and we use Ninja to like build the generated Ninja from GN. Right. And Skia install command, build in source. And yeah, so it's just gonna take a little bit of time and we should be good to go. And after we're done with that, what we do is we add a library, a static library that is imported, because imported means we're basically just gonna wrap over an existing built up library binary, kinda. So here we just say add, we add the dependencies. So basically to build this Skia library target, this CMake library target, you need to make sure to build this external project, right? And for this target properties, we're setting the imported location. Here you basically tell it which library you're wrapping. In this case, the library that this guy would generate is called libskia.a. Well, at least in Linux. So we may need like here an if condition to check if it's Linux or what exactly and match it accordingly. Other than that, we also add the includes. So anybody who actually links to our Skia CMake target here would get both the imported library and would get the include directories too. And so finally here we got our actual library, our own library, and we just too simply link to this Skia thing, which is cool. So now that we got that out of the way, we should be able to import Skia. Alright, let's try this out. I think it's probably SKSL, yeah. Alright, so right now we need to figure out how we could use this. I think it's probably built up. Alright, so apparently there's some examples here, I would guess. No? There's a Vulkan basic. Interesting. Well, we don't want to go into the backends just yet. I believe there's probably like some sort of you know, just a software backend which we could use to just test if Skia is even working. But wait a second, this Vulkan stuff seems too simple for Vulkan though. What the heck? Oh, I guess maybe they're using like SK GPU test. So maybe they're using some testing library they have in there or what? Wait a second. Backend context. Debug messenger, make unique Vulkan extensions. Yeah, there you go. So Skia have a test helper to create a Vulkan backend really quickly, apparently. So that's interesting. But they should not depend on that function. We may arbitrarily change it as it is meant only for Skia internal testing. As you can see, you're not supposed to use it, but additionally may do some odd things that a normal Vulkan user wouldn't do because it's only meant for Skia testing. When creating a device on your own, make sure to use SK GPU Vulkan preferred features to let Skia add features and extensions it would like to take advantage of. Performance may suffer otherwise, or some functionality may not be accessible. Interesting. So they just say SK GPU test, load the Vulkan library, and get proc ADDR functions, and they give it the inst proc here, which is this. Interesting. Create the Vulkan backend context, and then here we get the proc. You know what, can we just like copy this code and see if it even works in here? And apparently, what the heck? It's trying to say include everywhere, right? Yeah, that's wrong. So yeah, let's just remove these weird includes. And this weird src. These are private files. Clients would need to look at these and implement similar solutions. So I don't think these exist in here though. Obviously we also need Vulkan too. But hold on, what's going on here? So there's no Vulkan memory allocator, right? Why? Actually there is, but it's not like that, which is interesting. So it's basically the new name is this. So like the example is somehow, I guess, outdated or something, or what? And in fact, huh. Well, that's strange. And then GPU types. There's no GPU types. But I guess there's maybe SRC. Is that the case here? And what kind of like file they wanted? They wanted the GPU types priv and the Vulkan memory allocator priv. Okay, let's see. Vulkan memory. Yeah, it's right here apparently. Okay, so that's interesting. That's very interesting. So you know what we're gonna do? We're actually gonna go back. Yeah, we're gonna go back, and I think I know what I should do here. At least to get this example working. I think I know. So instead of adding the include directory, we're just gonna include the whole directory. And that should work out now. And there you go. So we fixed those, but finally we need Vulkan. So here we either include the Vulkan headers ourselves, or we choose simply just install the Vulkan SDK. And honestly, I would need the Vulkan SDK here. So let's go with Vulkan. I believe probably Vulkan tools. Not really. I think just maybe Vulkan. Because like there was like some sort of Vulkan group. Wait. Arch Linux Vulkan group package. Yeah, Vulkan-Devil, right. And this would basically like include all the Vulkan stuff for you. The Vulkan, the Spirv tools, the utility libraries, etc. The headers, whatever, you name it. All the Vulkan stuff you might need for development. So yeah, there you go. And now we have to restart obviously our editor. And now we should have access to Vulkan. Though generally you might also want to add add package Vulkan, but anyways. So yeah, I think right now we should be good to go, right? Let's try to run this now. But well, this is actually currently in a library. So that's not gonna work. Yeah, so let's just make an executable for now. We don't want to deal with that stuff right now. Let's just make an executable and let's just remove this stuff, and I guess let's just call library CPP right now, doesn't matter. And let's just remove this header, we don't need it. And let's go. And we should get an executable we could run right now. Although this is called library, but don't be fooled. Okay. Or you know what? I think we're just gonna like clean the build directories and rebuild. Wait, what? Well, that's strange. Bro, what? That's very strange. Oh yeah, this is amazing. So I guess let's try to move this, and let's try to move also this out right here, maybe. Probably. And I guess let's try again now. You know what? Let's just change the name. Kodoki. Okay, actually that's a cooler name, not gonna lie. That's a way cooler name, that's for sure. Alright, so let's try again now. Bro, what? Air out release. Bro, I'm so confused. You know what we're gonna do? We're just gonna remove this Skia directory altogether. It's just gonna suck, but honestly I can't think of anything better. And we're gonna remove the build stuff. And we're gonna do it again. Oh man. And yeah, let's just update all the submodules. And then you should add Skia back in. And then we're gonna basically have to rerun the script. Third. And let's hope for the best. All right. Come on, bro. What the Let's see if the AI could help with this, because what the heck is even that, bro? Alright. But well, it worked before. I don't get it now. You know what? Let's just try it anyways. Set property generated. Bro, what? Yeah, this is what you have to freaking deal with using CMake. But you know what? I've already done this a bit before, so hold on a second. Wait a second. Because it's not really what's it's really like surprising me here is that it works just fine off camera, but now nothing works, which is quite interesting. Okay, so this is what worked for me off camera. This is a script. Okay, so find Skia.CMake. Okay, so let's just, this is kind of the same thing, you know, as doing it in line, but you know, just a bit more like organized. But fine, let's just do it, because if this doesn't work, like, bro. Anyways, CMake. Let's create a new file. Find Skia.CMake. Let's add that, and let's just paste this in here. So as you can see, the same exact logic to some degree, just a bit different paths and stuff. But anyways, who cares? And here we go. The stuff that I was trying to do, which is synchronizing using CMake. Other than that, we're just gonna take this guy and just paste this in here now. And let's see if this works. Because if it doesn't, I have no clue what would. And it works. I don't really understand what was the problem. It's probably some weird, stupid CMake thing, you know, or like path thing, or yeah. But anyways, I I'll probably just, publish this repo at some point. So if you're following up with me, you could just like copy my CMake pretty much, and it would just work out just fine. There you go. And this is actually even giving you like the, oh, it's actually using this official build, true. Interesting. But no, I did have like another script. There you go. There you go. Yeah, we could add that. Honestly, let's add that now, so we could have some debug symbols. Sure. All right, so just gonna copy this part here, and we're gonna put it in here. Actually, not there. Let's put it in here. Fine. And let's just, instead of that configure command, we're gonna add this instead. And that should, we just basically replace those arguments with this variable that basically changes dependent on the CMake build type. So that's cool. So if like we are in debug mode, then we go with non-official build. Is debug equal to true and is component build equal to true? Otherwise we go with this for the release mode. But yeah. All right, so let's try right now compiling the debug mode thing. And there you go. Honestly, you know what? We could actually ask the AI what was the difference. Like, why the heck that didn't work for me? That didn't work for me. Why this does though? What's the difference? And let's go. Oh. Okay, so apparently I had that being a static target. So that's why. Cool CMake. Target include directories interface. So that was the problem. What I'm doing with my life. Anyways. But after this, we should have a pretty good working build from source. But yeah. Hello, Niran Gentka 2676. Welcome to live stream. Alright, so mic is on, camera is on, sick. But anyways, so right now we're compiling Skia from source. Anyways, let's actually read the code that we have here. So right here we're just like configuring the Vulkan context and Vulkan backend. Vulkan memory allocators make. And here we're making a context out of that Vulkan backend. And finally we're making an actual, Skia image that I would guess maybe here it's 16 pixels by 16 with RGBA 8 and pre-multiplied alpha, and then we create an SK surface backed by a Vulkan VK image. Wait. So often clients will be getting VK images from swap chains. In these cases, wait. So that's why the Vulkan code is so small. They don't configure the swap chain and the window and all the other crap. They're just like making a Vulkan image. And just using that for testing purposes. Okay, anyways. So in those cases, they should use SK surfaces wrap backend texture or SK surfaces wrap backend render target to wrap those pre-made VK images in Skia. See the Hello World example app to see how this is done. There's a Hello World example. And oh, we need to also fix this little thing here so the example works. But let's wait for this Skia library to compile first, and then we could fix that. After this, hopefully we can get something working. Because what the heck was that, bro? Right. And this is exactly how CMake basically kind of like consumes all my freaking time. So like I just started a project, I want this library, and yeah, here you go. There's a CMake error that you have to handle now, and there's no tutorials about it, by the way. So the Skia used by Flutter, right? I'm a Flutter developer. So, oh yeah, Skia. Well, Flutter doesn't use Skia anymore, but yeah, they were using Skia at some point for rendering. So yeah, so kind of like not building using Skia, but like kind of like building our own Skia, like building our own Flutter actually. No, building our own Flutter instead of using Flutter. Alright, so let's just fix this little thing because the example actually kind of expects this kind of weird stuff. It includes also the source, which is not a good thing because these are supposed to be private files, but just for the testing purposes, we're just going to fix that too for now. So let's see. So here in target include directories, we're going to remove this include for a second here. Just so we could test this really quickly. And boom. Now let's try to run this again. And we still have some problem apparently. Why? So apparently we don't have this SK GPU test. It's probably gonna like enable something in the arguments, but let's see. Really? Let's check out some real example, bro. Right, where's Skia? Here we go. Graphite. Okay, so we want graphite, I think. And yeah, there is graphite native Vulkan. I mean, we could just try to fire up our own like Vacay images and stuff, but This will not run since it's missing all the Vulkan setup code, but it should compile link to test the build system. Alright, so that's exactly what we want, bro. Please. Alright, let's see. And yeah, this one doesn't seem to have any errors at least, and it's not using some weird private files or test thing or whatever. Build finished. Okay, and error running. Why error running? What? Executable not specified. Why? Bro. Oh. Let's remove this static thing. Come on. Bro. This is insane. You know what I'm gonna do? I'm just gonna create another executable here and see if that's the problem by any chance. This action is not available. Really? I swear to God. Welcome to the C++ development experience. Yeah, I want to analyze the project and it's just going through all the Skia third-party stuff. Oh, crap. Crap. Now you know how much work goes into one video. of my like tutorials of setting up like libraries. Oh crap, man. Let's go. We should have just used VC package, to be honest with you. But again, probably I would have found other problems with VC package too. I'm pretty sure about that. Like a missing Vulkan backend or some crap like that. So I'm just waiting for this to analyze the project because the IDE really suck for whichever reason. It doesn't allow me to do anything. Yeah. And there you go. It just froze up. Bro. Seriously? It started analyzing again. Swear to God, bro. Yeah, just, I don't know what's up. The same problem again. This is why I just used Bazel, since Google only really supports GN and Bazel. I mean, it should work. I don't know what the hell is going on here. Okay. Okay. What are we gonna do about this? You know what? Let's try some AI agents, okay? I've not tried AI agents a lot. I just found about AI agents like just yesterday, I think. Like before yesterday, I was like exploring this space. And I found out about open code, which have a free model which we could use. So let's actually install that and see how far we can go. So yeah, all right. So let's just go ahead and see what's up, if this would save the stream or not. And we're gonna install it using Paru because I'm on Arch Linux and I have the AUR. So we're gonna say Paru-s open code, and boom, let's go. And let's see if the agent would actually figure it out or no. I'll just start by just telling it exactly what I want and see what it's gonna say first. I'm not gonna like tell it anything and see what it's gonna say. And there you go, open code. Boom. And we're going to be using this big pickle model, which is like free. And we're going to go to the plan mode using tab. And let's see if it can do it or not. So we're going to say, set up a Skia C++ 26 and modern CMake project. Let's find out. So we're just in plan mode right now, which means it's not going to try to create any kind of library or anything. What the heck, bro? I've gone and read my existing project. Okay. Oh crap. What the heck? No, I don't want you to do that, bro. No, that's cheating. The agent have cheated right away, bro. No way. Okay, so you know what? I don't want you to do that. I'm just gonna remove the whole C-line project. What the heck? You just cheated right away. Bro, I mean, it's smart. Bro. But you know, let's just see again. Let's try again. Make a C++ 26 and modern CMake project set up using Skia and Vulkan. Well, just Skia using a minimal, make a minimal, yeah, minimal C++ 26 modern CMake project setup using Skia. I think that's probably, and git submodules, fine. Let's add that too. Right? I think that's good. And let's see. I could have told it like actually what's wrong with my thing. And in fact, I probably still have it in my trash. Maybe, I don't know. But anyways, let's just see what the agent itself would say. So in planning mode, it doesn't try to create anything or like write any code. It mostly just research and read your file system, etc., and run commands, and just helps you kind of plan out essentially the project. So we're gonna start with that, and we'll see what it's gonna say, what it's gonna do. It's reading project for whichever reason again, which is very strange. Oh, my bad. I see why it did that. Yeah, I forgot. My bad. It's really my bad. You know why? Because I ran it inside of the home directory. So what I actually should do is make there and code OK, fine. Honestly, I liked code OK more. It's such a neat name. So let's go with that, code OK. And fine, let's try again now. So now we're gonna run open code here. And instead of build, we're gonna go to plan mode. Bro, man. All right, anyways. What is this text tag with this? I wanna make a modern CMake and C++ 26 project with a minimal Skia setup using, let's just tell it the details, fine, external project and gets, because otherwise we're just gonna stay here. Although I'm kind of honestly, yeah, let's just tell it the details. We don't have that much time to waste, and get some modules. All right, and let's see what's gonna do. It's taking some time to think. Empty directory, good. Let me check what tools are available on the system to inform the plan. So it ran this command and it checked the versions. That's sick. Interesting. No GN. I'll tell it that the GN should be like generated using the script. Fine. I would have really wanted to just tell it nothing and just see what it does, but honestly we don't have that much time to waste at this point. Good, we have modern tools, but no GN installed, which Skia needs. I have a few questions before I write a plan. So Skia uses GN for its build system, not CMake. How should we handle GN binary? You see how the agent is like? You know, it asks you questions, good questions and stuff, so that's cool. Okay, let's see. Auto build GN via external project recommended. Okay, so from Skia's fetch GN script before building Skia, fully self-contained, and it says recommended, so that's kind of good. Assume GN is pre-installed. Nice. And use Skia experimental support. Okay, so bootstrap, I think, yeah. So let's just answer it ourselves. Let's just tell it to use fetch depths. Just run the fetch git fetch depths Python script inside of the Skia subdirectory, and it will fetch the external dependencies needed for you, and also the binaries like gn inside of the subdirectory tools folder. Next up, the next question is, what kind of minimal Skia demo do you like? Off-screen rendering to PNG? Exactly, that's what I want. I don't want any OpenGL, no Vulkan BS. I don't want any of that bullcrap, because that's another story to set up. So yeah, please. Which compiler config would you prefer? Let's just go with the system compiler, although I kind of like Clang more, but anyways, let's just go with that. Next up, what we got? Just run the git fetch depths. Okay, so let's see what it's gonna say. So these are my answers. So you see how the agent works? I didn't know it works this way until I tried it, and I actually didn't try it because of the agents. I tried it because I was trying to optimize the best local LLM I could on my system, on my RTX 3050 6GB of VRAM, which is not much. So I wanted to squeeze as much as possible. So I was researching about like NVIDIA libraries like TensorRT and like all the C++ libraries and stuff. And honestly, I did find something that is supposed to be optimized, and I kind of learned a lot about the AI ecosystem too. Which I might go into at some point, maybe some separate live stream or something, I don't know. But yeah, anyways, so let's see. Great choice. Here's the full plan. So the plan is Kodoki, modern CMake, C++26. It would include CMake presets. Cool. Git ignore, git modules, sick. Executable target, main.cpp, off-screen Skia demos, nice, perfect. CMake, okay, so we added a folder build skia.cmake, sick, lovely. All right, so we did add that git configure command directly that we wanted. Perfection. Nice. Creates an imported target, perfection. CMake minimum required, fine, I don't care. I don't care, cool. Yeah, that seems sick. GN args, so is official build true? Skia enable GPU false. We don't need GPU for now, at least for now. Later on we want that. And SVG false. Scotty, no. PDF, no. FreeType, no. We might enable GPU later, but for now, let's keep it dead simple. Let's produce a CPU-only lib Skia. So as you can see, this is what's nice about building Skia from source. You could remove all the BS that you don't use. No external system libs except pthread, DLM, fine. I don't think those are probably required, but anyways. Minimal demo raster, cool. Amazing, perfect. Skia commit panel, pick a recent stable Skia commit, any preference? Oh my, this is lovely, okay. Cool. Sick. All right, so we're gonna right now go to the build mode and just tell it to build it. And let's see what it's gonna do. Alright, so we made the plan, as you can see here. You could even get LNSP, but it's disabled in this case. And I already lost track of what the heck it was doing, but anyways, let's just keep going. Yeah, just create some directories there and a git init. Cool. And it generated this CMake preset, which uses GCC. Sick. So far, so good. And let's see if AI would replace us. Oh crap. Alrighty, that looks good. Hello, Sanatani89. Welcome to live stream. Okay, add Skia as get submodule. There you go. It's adding right now Skia as a submodule. Perfect so far. Nice. Alright. I don't know if it's gonna make it from the first try, but so far it seems good. So as you can see, it's using the latest C++ features like auto and SED print line. Sick. All right, so it's gonna take a bit of time to, you know, fetch the git Skia submodule. Hopefully Google wouldn't rate limit me, because I've basically used that crap for like 2 times now. If I use it the 3rd time, I might get throttled there, but hopefully not. Let's hope it's not. I've just finished Vulkan Beginner, taught by you. It was good actually. Any plan on making advanced Vulkan tutorials? Which one exactly? Which kind of one? Because I've made a lot of Vulkan tutorials. Can you tell me the details about which one you watched? And by the way, guys, if you guys have any questions, please let me know while we're at this. Writing command. Okay, get status cached. The one with the ceiling. Okay, so that was like my oldest one. I was like the most beginner at the time. What I would say for learning Vulkan. Configure to see that this will run. Wait a second. Oh, it's trying to use the Skia build. No. It should go to the tools. But I think it would probably just figure it out itself. Yeah, there you go. It would fix that, as you can see, by itself. Yeah, it did fix it. So that's nice. Anyway, back to the question. I think if this is, wait a second, let me just make sure that this is okay. So I think it's maybe reconfiguring building right now, or what the heck is doing right now. I can't really tell. Anyways, so for Vulkan, I would honestly really recommend checking out my latest video about Vulkan. Or live stream, I don't remember. Anyways, video or live stream about Vulkan, where I use the NV Pro Core 2 framework, because if you keep on doing Vulkan by yourself, like everything, like the context creation BS and all that crap and all sorts of things, you're really gonna get burnt out so badly, and you're not gonna do anything. You're not gonna continue. So I really, really recommend trying to use that framework that I've covered in my latest video or live stream. I really, really recommend using that instead. Because then you can like focus on the actual rendering instead of the Vulkan BS, you know. So it would really help you a lot. It'd save you a lot of time. Because, you know, once you get through that whole, you know, ceremony multiple times with Vulkan, like you just get exhausted. And you just get burnt out, and then you just leave, and you just end up with nothing. So really, I really recommend trying that one. Though it's not C, that framework is in C++. But yeah. You appear to have cloned an empty repository. Oh, wait. Alright, there you go. So we're trying that script right now. Cool. Yeah, I'm okay with C++. Yeah, I really, really recommend watching my latest video about Vulkan. That's NVPro Core 2 NVIDIA framework. It would save you tons of time. Okay, and tons of your sanity too. Because without it, you wouldn't really continue. Okay, so what's trying to do here? It's trying to do the temp stuff for whichever reason. Why that's the case? What it's trying to do here? Oh, it's just trying to, I guess, test GN using the temp directory. I mean, allow once. I don't know why, but anyways. Yeah, so just testing a few things in the temporary directory. So I just enabled it for once. And let's see what's gonna do next. It's probably testing like the maybe the arguments there. Yeah, and it fixed that error that we have gone through too. As you can see, I'll combine both configure into a single. Oh no, what? No. Oh wait, what? Or actually, maybe it's good. Maybe it's fine. I don't know. We'll see. Yeah, so right now it's having problems with the quotes in CMake. So we should just like remove the quotes. Maybe I should just like interrupt it and tell it that. Yeah, let's interrupt it, fine. Remove the quotes from the CMake Skia args, because it doesn't work that way. And let's see if it's going to take that input into account so it saves up some time. I think I'm pretty sure it would figure it out by itself, but we don't have time to lose right now. Yeah, let's see. No way, wait a second, don't do that. Don't tell me it's gonna do that shit. No way, the wrong crap, bro. I think. Bro. No. What the heck? Wait. Actually, you could actually also undo like the file changes too. I mean, that's what it said, so I would guess so. So maybe I could just do this. Would that work? Remove the quotes from the CMake Skia arcs because it doesn't work that way. From the yeah, this is insane. I don't know what the heck it's doing there. You know what? I'm just gonna not tell it anything and see what it's gonna do by itself, really. Anyways, I don't care. Just continue. Yeah, let's just see what it's gonna do. Because it's just not getting my input well. It's kind of like maybe interpreting it like there's something wrong with the arguments of Skia itself instead of the actual CMake syntax thing. Maybe I should have I could have specified better, but meh. Alright, it seems actually building now. What? I mean, at least I could hear my computer going crazy. Would have been cool if I'd seen some progress there. But yeah. I mean, am I right? Let's check it out. Just to make sure. And yeah, look at that. It's going insane. There you go. Compiling. Uh-oh, it failed. Why? What it did wrong? Skia built, but Lincoln needs whole archive for the bundled depths. What? I don't even know what the hell is that. Was that the problem that we had? Man, you're watching a master at work. It wanted the temporary directory for some reason. Fine. Okay. I'm not sure what it's doing honestly exactly here at anyways. Maybe it's like noticing that it's maybe missing some things there, but like some arguments. Build succeeded. Really? And it's done. Well, that's insane. And it did it. That's crazy, bro. That's crazy. I don't know what was wrong with our setup. I've seen some crap about bundle, I don't know. I mean, we could actually just look into the exact things that it did. We are cooked, yeah. Oh my. Alright, so let's actually see what the code it did here. Alright, so yeah, let's open it in C-line and let's actually see what it did, how it solved the problem. Because this is insane. We are cooked. Okay. Alright, so let's open that up. Kodoki, right? Or what was it? Oh boy. Where the heck is it? Bro, what? There you go. I don't know why it didn't show up before. Okay, let's see what the heck is going. Okay, nice. It gave me even like the presets, which is sick. Love that. No thank you. It tried to attach the Rust because like in Skia there is some Rust stuff there. I'm gonna remove that default debug thing. I'm gonna use one of the ones that which build they actually even used here, by the way. It uses build release, so let's use that so it doesn't have to like rebuild the whole crap again. So we're gonna go with, I believe this one, or yeah, which one? Wait, which one it used exactly? Default, I think. Default? Yeah, I would think so. Yeah, fine. Let's enable that one. And let's say okay. And let's see what we got. So, first of all, we got the CMake list. And the CMake list, this is what we got. So, perfect. Try to find package thread Python 3 and threads. And then I included the CMake / build Skia.CMake. Cool. And here we got the third party Skia submodule. Sick. Okay. And boom. So this is the whole thing. And my IDEs right now is going crazy with analyzing the whole Skia stuff. Yeah, it's lagging. Ouch. Anyways, so it's set to the Skia source directory to third party Skia, then the binary directory to Skia build. Oh. It actually managed to build Skia outside of the source code too. That's sick, bro. Set Skia GN output directory. Out release. Out release. Yeah, okay, cool. And Skia GN arcs. So this is the ones that we could, like, you know, play with. If you want SVG support, then we could just plug this in into true, and then it would just rebuild the whole thing and give you SVG. Not the whole thing, but like, I don't know. Actually, probably the whole thing, because it's not part of the CMake stuff. So I'm not exactly sure though, so I can't really tell you. We'll see. Anyways. And here it's replacing spaces with nothing. So it's removing spaces from this. Interesting, weird, but okay. And it's replacing semicolons with space. And then external project add. Source directory, binary directory, download command, nothing, update command. Nothing, cool. And then the configure command, it's using sh. It's going inside of the directory, using the Python 3 executable to sync deps, and then bin-gn, and then it's running the generator, the Skia generator, with the arguments, and then finally building with Ninja. And here it tells exactly what byproducts for the build is, which is libskia.a. And then finally it just adds for the modern CMake target, just for convenience sake. It's called Skia static, not interface. Okay, imported global, and it adds the dependencies, this target to Skia external. So when we try to link to Skia, it would make sure that this external project gets compiled. And finally we set the target properties to imported location, libskia.a, and the interface include directories is the actual source directory, not /include, just like they did with the examples and stuff, so that's okay. And yeah, so that's the way to build CMake Skia. Pretty cool, huh? So you just, like, you know, clone the thing and it just works. So yeah. Next up, we got the source here. So we got our Kodo key here, and we link to that Skia target that we built and whatever this is. And we make sure to set the target properties runtime output directory to the CMake binary directory. So we make sure that it finds the, you know, the libraries to link to. And there you go, done. That's all. And finally here, the C++. So it's including SK Canvas, SK Paint, obviously from the core, SK Stream, SK Surface, and include encode. Encode SK PNG encoder. So I would guess we have probably multiple encoders, right? Can I see them? It should open the weird. Anyways, let's go to the next thing. Apparently we don't really need these, but fine. So the width is this, the height is this, and the main print line. So here we created image info. Make in 32 pre-multiplied. So basically 32-bit image pre-multiplied, which is kind of like how you deal with the alpha. The width and the height, then we create a surface out of it, which is in this case a raster surface. If not surface, then we just print to the SCD error and then we return. And then we grab the canvas from the surface, and we probably use the canvas to draw then, right? And then here we clear with a white color. Then we create this SK Paint, and we set anti-aliasing to true. Then we set the color red, and then we draw a circle using the canvas. But what the paint is for here? Yeah, we use the paint for setting the anti-aliasing and the color. Draw a circle, you give it the center X position and the center Y position and the radius of the circle in floats, obviously, and I would guess in pixels in this case, probably. Yeah, and then you give it the paint. So SK Paint is basically controls options applied when drawing. Okay. And then here, blue stroke border. Okay, so it's actually reusing this paint instance here. So it's setting the style to K stroke style. Set to stroke geometry. Okay. And then here it's setting stroke width and setting the color, and then finally drawing the circle again. And came back. Alright, so this is how you switch between strokes and fills. You just switch the style. You set the style to either SK Paint key fill style or K stroke style. And it's still analyzing the damn project, which is annoying. You know what? Maybe I could help the IDE by removing the third-party BS from here. How can I filter it out? Wait. I believe there is a mark directory as, I think, excluded maybe? Is that the case? Probably. Hopefully that would fix it, because what the hell? Because when it's like indexes my project, it just goes through everything, including this third-party libraries crap, which takes years. And alright, so that just got stuck in there. Well, that's cool. Maybe I could close it and open it again. So this is way better. Way better. Alright, let's go. Come on, open up. And we go to the next thing here. So that was the blue stroke border for the draw circle. Next up we got the set style, K-fill style, color green. And we draw a rect, and here make X, Y, W, H. So the width and height, obviously. And the X and Y, okay. And then we use the paint again. Cool. And then finally we encode to PNG. Make image snapshot. Returns SK image capturing SK surface content. Subsequent drawing to SK surface contents are not captured. Alright. And finally, we use a PNG encoder to encode the provided image. Alright. And it returns the resulting bytes of the encoding. Alright, so if we're using the GPU, then you gotta give it the context of the GPU that you're using. Otherwise, if it's just raster, in this case, you could just give it null PTR apparently. Cool. And then here we got SK file W stream. Alright, so we're just opening basically a file stream here, kind of like a CDIF stream with output.png. And we're just writing the data of that encoded image. And yeah, that's all. And that's how we do it. So now what we're gonna do, I'm gonna tell the agent to make sure, first of all, to like use git, commit this, commit this changes, right? That's the first thing I'm gonna do. I always forget about that part. And it added the idea to get ignore, which is sick. And these files, I'm not sure what those are exactly, but yeah. Kodotaku users no reply github.com. Crap. Okay. Who cares? Committed as with, so cool, lovely. So where are we gonna go next? We should try some GPU stuff. All right. So wait, should we go with let's go to maybe planning mode first. Yeah, let's go to planning mode. Let's actually ask it itself, where should we go next? And let's see what it's gonna say. Good question. Here are some natural directions. Windowing plus real-time rendering. I think let's add SDL3, right? SDL3, yeah, sure. Let's start with that. We'll add SDL3. As for the backend, what backends there is available. And then it probably would go and look for the actual source code and check which backends there is, so we can have some, you know, up-to-date info. So no Dawn. Can you check the source code? Make sure you list all the backends, because it didn't seem to do that. So we have a full picture of which options we have. Currently, I think either Dawn or Vulkan. I have most of my experience with Vulkan, so maybe we'll go that way. But we'll see. So we got Ganesh, no, completely off. And for Graphite, which is the new one, Um, there is Web GPU, KDawn, and KVulkan. KMetal obviously is only for Apple, macOS only, and KMock for testing. Sick. So either Dawn or Vulkan, pretty much. So Web GPU or Vulkan. Which one we're gonna go with? I really want to go with Vulkan, to be honest with you, so I could make use of all the tricks that I learned about Vulkan, the libraries I know, etc. While Dawn is also nice, so we don't have to deal with Vulkan bullcrap too. But again, I want to use the Vulkan modern features, so I get both, like the best of both worlds, to be honest. Well, we'll narrow the search and see what the agent will say. Either Dawn or Vulkan. I'm not interested in backwards compatibility. Probably Vulkan, but we'll see. I'm trying to keep an open mind. So if we use Dawn, then also the browser would be on. But again, the browser would add some extra complexity. Actually, apparently it says that there's more complexity in Dawn for whichever reason, which is interesting. Weird. Portability. Yeah, I'm not interested in mobile, to be honest, and browsers, because they just add a lot of friction, and I can't use like the latest modern features, and you have to constantly think about cross-platform and if my dependencies works, etc. It's just a pain in the ass. Yeah, because like, and if I use SDL3 integration, as you can see, I'd have to deal with the native window handles via SDL properties, which sucks. While for Vulkan, we have SDL Vulkan Great Surface. So yeah, we're gonna go with Vulkan. We're gonna go with Vulkan 1.4. So like the latest Vulkan with the most modern features. Sure, that would be cool. I've never vibe coded Vulkan before, so this is gonna be very interesting. Because it's gonna be vibe coded, yeah, but it's gonna be with my own direction because I know what I'm doing. So this is gonna be very, very interesting because I could let my vision go while the actual agent do the hard boilerplate code and work. So yeah, both are fairly modern. Okay, so we'll use SDL3 with Vulkan 1.4, and I'm gonna just narrow my target. I don't care about mobile nor web. I only care about modern desktop GPUs. So we don't bother with that bullcrap, right? And that would really help a lot. Narrow the scope. Because cross-platform just comes with a lot of headaches that I really don't want to deal with. And especially the agent is gonna be like verbose about that if we do include those too. So yeah. Makes sense. Let me research the current Skia GN flags for Vulkan and check SDL. Okay, so let's see what it's gonna say. Would have been cool if it was a bit faster, but hey, this is what we got. I mean, it's free. And technically it's not perfectly free. You should be careful to use this on like proprietary code or like private code, because it's probably using it for training and such. But in my case, I don't care. I'm actually gonna make this open source. Permission required, access external discovery. fine. Fine. It's just reading stuff. And also another problem with the open code is security concerns, because as you can see, it's just like doing whichever commands mostly, which I don't really mind, to be honest with you, in my case. Access external this directory. I'm just, you know, risking it. Yeah, like best, if you're really concerned, you could use Docker. You could make it inside of Docker and just let it go wild. But that comes with its own complexities too, obviously. And also less performance and crap, but yeah. So yeah, all right. So as you can see, instead of going into the web, it's just like reading the source code by itself. So it could provide me with features like suggestions essentially and stuff, up-to-date ones, but yeah. But anyways, and in fact, if you click on this, then you get exactly what it's thinking about there, but I'm just gonna go with up arrow to go back. So as you can see, it goes through, it actually spawns multiple sub-agents. So each one does something, as you can see. And right here, it seems to be researching or exploring the SDL3 source code, which is interesting. And also Skia right now. And I think it's done now, yeah. So it does research, does everything for you, which is lovely. Good research findings. Let me also check what Vulkan components are available on the system. Ooh, okay. Will it use the Vulkan? Yeah, I should tell it to check out my extensions and to yeah, it's reading a lot of source code there from Skia and from my system too. Perfect. I wonder, like, the people who have like paid models, bro. That's gonna be insane, man. But obviously you need to know what the heck you're doing, that's for sure. But other than that, it's also reading this example Skia Vulkan Basic, okay. Alright, so here's the plan I made. We'll do it properly with SDL3 plus standard Vulkan APIs. Should we use the system one or should we add it as a submodule? Oh, we should probably add a submodule too, because why not? It would be also great for the agent, so it doesn't have to go to the system every time and ask me for permission, which kind of sucks. Enable Ganesh false, enable graph fight, true, cool. Use Vulkan, cool. GL false. Use VMA, new, auto enabled with Vulkan, perfect. We want to use VMA. And yeah. So it's gonna init SDL3 video. It's gonna create a Vulkan capable window. It's gonna load Vulkan, get the extensions, create the Vulkan instance with SDL extensions, pick the physical device. It's probably not gonna use a dynamic rendering other modern features, so we're gonna tell it to do that. VK enumerates physical devices and get presentation support, create the Vulkan surface, create the Vulkan device, and present queues. Create the swap chain, build the Vulkan backend context instance device queue get proc. Vulkan allocators make, create Skia graphite context, create a recorder, main loop, acquire the swap chain image, wrap the VK image as backend texture, wrap as VK as SK service, draw it. Cool. Alright, so I'm gonna tell it to first of all see the current available extensions on my card using some command. Detect the Vulkan extensions on my card. Let's start there. There you go, it's using Vulkan info. Perfect. And boom, it just, bro. Swap chain maintenance 1. Let us reset fences on swap chain perfection, bro. Synchronization 2. Dynamic rendering. So I just told it to detect the Vulkan extensions I have, and it just gone straight to the jugular vein right there. Timeline semaphore, efficient GPU sync. Memory budget, present ID, present weight. Do you need loading, like loading? Do you need dynamic, like, wait, no, a Vulkan meta loader? Or does Skia already have something for that? Built in. We can either use Vulk. Otherwise, we can either use Vulk or VK Bootstrap, which would also give us good swap chain out of the box. Well, I didn't know I was going to be using like the agent in this stream. I would have actually added agent, and I didn't even know I would be using Vulkan either. But as you've seen, without the agent, Ski was a hell to set up. But yeah, Ski has its own, good question. Ski has its own built-in function pointer table loaded lazily via fket proc callback. We just provide. But we still need function for our own work. Creation, swap chain, queue, present. Ski doesn't handle any of that. Static symbols, hell nah. Hell nah. No. It doesn't use Vulk internally, I don't think. No. It doesn't use Vulk, I think. Rapid skip proc. I'd suggest VK Bootstrap given the complexity of swap chain surface and perfect. So I just was kind of thinking if Skia give any kind of helpers already, which would cancel one of these or both, but apparently it doesn't really. So we could use VK Bootstrap. I don't mind. Other than that, yeah. Alright, so devise a plan for making Vulkan 1.4 modern render only for desktop modern GPUs like mine, with the extensions you have available. We might want to include the scripture heap too at some point, and mesh shaders, etc. But for now, let's keep it a bit conservative just for testing. Yeah, I think use VK Bootstrap unless if it would bother you using the modern swap chain extensions, and would hopefully yeah, just that. For now, what's required is dynamic rendering and sync 2. So I'm really narrowing down the platform, the target. Not really interested into cross-platform stuff. Alright, let's see what's up here. What it said. Okay, so yeah, fine. For now, we'll keep a system package. Later on, we're gonna use the submodule instead. Okay. VK Bootstrap, new get submodule, instance device, swap chain creation, balls func, existing submodule. Yeah, sure, keep it in one file for now. I'd like to also include the SDL main callbacks, but not now. Let's just get at least something working. Covers dynamic rendering plus sync 2. Add SDL instance extensions, debug messenger. VK Bootstrap device builder at pnext. Oh my god, agents are made for writing Vulkan, bro. VK Bootstrap handles color management. Perfection. Seems good so far, but it didn't like address my concern about VK Bootstrap swap chain. Yeah, for now, just keep it in one single file. Look at that, it's using web fetch to fetch the repo files to see exactly if it does or not. Like, bro, good catch. Let me actually read the swap chain builder API to check. Looking at VK sources, just fetch. Here's the deal. And device level plus feature and required extension and required extension features. What the? Wait, go back. Nice. Nice. So cool. DL3 for windowing. Looking good. How about VMA? Does Skia include something for that? Or should we include ourselves? I think that's the last question I have, I think. Then we'll probably just let it go ahead and implement it and see what it's gonna do. If it's gonna make it or not. That would be very, very interesting. Ah, crap. Because, you know, I'm not going to implement it myself, so I could go wild. Is the live stream still on, by the way? Yeah, no dropped frames, so that's cool. Okay. So yeah, I think it's probably already included. Already bundles VMA, yeah. Okay. So yeah, I think so. Right now we're just gonna let it implement it. Great, so the plan is clear. Sure. Build it. And let's see what it's gonna do. This is gonna be very interesting. So right now it's just reading source code and gripping stuff. I wonder if we like give it the LSP, would it be better to? I think it would. But anyways. Oh, it's taking quite some time though. Oh boy. Maybe it just stuck. Maybe I should. Yeah, I think it's probably stuck at this point. So, oh, okay, never mind. I almost interrupted it. Well, I thought for 2 minutes. That's a philosopher right there, huh? Now I have all the context. Let me start implement. First, add the VK Bootstrap submodule, examine its API. Sure. Well, you know what? Just always allow, I don't care. Just do it. If the system goes down, you know why. That's why I should probably just like include the Vulkan headers and like the SDL, all the libraries inside of my repo, so it doesn't have to constantly ask me for permission about system directories. So yeah, nothing fancy going on here. It's pretty much just reading about stuff and thinking. Yeah, I've already used 50% of our context. Come on. Well, it's taking some time. Okay, so right now it's actually implementing that. Everything good so far? All right, now the big one. All right, let's see the big one. I mean, it shouldn't be actually that big, to be honest with you, because we're using VK Bootstrap, which really simplifies a lot of things like swap chain creation and like physical device selection and stuff. And we're also using, what is it called even? Skia, right, for rendering instead of like doing our own rendering. Actually, do we even like need dynamic rendering if we're using Skia to render? I'm not sure. We'll see. We'll see how it works. Because I don't know how Skia would integrate exactly, and I guess we'll have to find out. And honestly, speaking of which, maybe we should add FFmpeg into the mix and try to make a crazy video editor. But before that, we should probably have the Yoga too, Yoga layout engine. But yeah, anyways, we'll see. But let's keep this simple for now. But yeah, adding, or even like adding Lua to the mix too, and adding Jolt physics, yeah, crazy. But wait, Jolt physics. Well, we don't have 3D now. I'd use a Skia video editor for real, but like video editor would be insane, man. Would be insane. But like we could probably do it. I mean, we're not gonna be implementing that, so. We're just gonna be planning. The agent would do everything. We just have to make sure everything goes well. It could definitely go wrong. But yeah. Well, let's see first of all what it's gonna do. If it's gonna successfully make the Vulkan thing first. It seems to be building stuff right now, so I guess fine. It didn't get any error so far. Yeah, there you go. We got some errors. But I think, yeah, it would be way faster at like fixing errors if it had access to the LSP. I should check out how I could actually do that. And yeah, what it did wrong there, I'm not sure. But wait, it's using vk destroy semi. It should use the vk bdev. It should use the dispatch table that is given to it by the library, by vk bootstrap. I don't think it's doing that. Build succeeded. Let me run it. Boom. Core dump. Segmentation fault. Okay. So the agent got segmentation fault for creating a Vulkan engine. Alright. Okay, let's see what it's gonna do about it. I mean, if it's really smart, you could make use of GDB. Just disable like interactive mode and yeah, figure it out. But let's see what it's gonna do. If it's gonna fix it or not. Even if it doesn't though, we still got a great prototype to start off, writing our own thing and figuring out what the heck is going on there. Instead of just blindly like, what the heck is Skia is engineers wants us to do here. And right now it reached 70% context window, so we have started to do some compaction. And what compaction mean? It basically would take all the stuff that it done so far in the context and it would compact it down into, you know, as you can see here. There you go. So we can free up some context memory. So right now, as you can see, it's gone from that 70% to 8% context memory. Look at that. Yeah. But yeah, anyways, let's see what it's gonna do. Actually, did it like enable the validation layers or no? I don't know. Really? I mean, something worked. There is a whole bunch of validation errors. And actually, it's saying faulted again. Okay. But at least you get something to the screen, so that's interesting. Not bad. Not bad at all so far. Good progress. The frap passed now. These issues remain missing. Maintenance and system for reuse. Need present fence. And segfault during cleanup from VMA outliving the device. Alright. Yeah, it seems great so far. Seems great, huh? I'd like to read the source code or like the messages beforehand, but I don't want to miss anything that it's doing currently, so I could interfere at any point if I see it doing something sketchy or strange. That's why I don't. I always keep an eye on it, essentially, to some degree. Verify, build, and run cleanly. The nice thing is that I don't have to interfere. It would keep going until it fixes the errors. And yeah, it ran with validation layers. Cool. And now I added get surface capabilities too. Okay. It should also try to include the Skia extensions. So I don't think it's doing that. That's why maybe it's getting all these errors. Sig term. 0 leak, 0 sig fault. Wait, what? Okay, cool. All fixed. Okay, so I guess it's done. I think so. Yeah, I think it's done. Well, let's just use this, I think, fine. And let's try this. And this is the code it wrote. So we'll have to find out if it's doing a good job. But first, let's see first if it's working as it's have claimed. So it seems to be linking for whichever reason. I'm not sure why it didn't just use whichever binary it generated there, but okay, whichever. And there you go. But it's not resize. Okay, so it didn't handle the resizing. It's just cheated. It just deactivated the resizing. But okay, seems working fine without any validation errors so far. And yeah, boom, it did it. It freaking did it. But now let's see the actual code. Let's do a code review and see if it really done a good job or not. So we made a frame data where it basically put all the semaphores in the SK surface. Transition command buffer. Present fence, a present semaphore, render semaphore, and acquire semaphore. Okay, and a vacate check with the string view message. Alright, with the CD format, alrighty. If not, SDL NH, SDL NH video, SDL get error, return 1. And then it's creating a window. Cool. And then it's getting the SDL Vulkan get extensions. Perfect. And then it's creating an instance builder and enabling the extension. Okay. Instance builder, it's setting the app name, the engine name, the API version, the use default debug messenger, enable the extension, get service capabilities 2, and get surface maintenance 1. I'm not sure what that for exactly, but anyways. And we're destroying the window, whichever. And finally, we're getting our instance here. And then it's using SDL to create the surface. Perfect. It's enabling swap chain maintenance 1 features, present ID and present weight. And here a physical device selector, and it's giving it the instance and the surface. Perfect. And it's preferring a discrete GPU and with the minimum version of 1.4 with these required extensions. Perfect. And these features, and then it's selecting it. If you would do this stuff like manually, this would have been a wall of text, bro. But sick anyways. And we got our physical device. Next step, we're creating our device and we're building it. Cool. But what? That's all? For creating the device. Okay. Weird, but fine. Destroy the surface, device. And finally we get the graphics queue and present queue. Sick, but it's not using this present queue for whichever reason, but whatever. Swap chain builder, set the desired format. It's basically wanting this guy, otherwise this guy. And then the present mode, the desired present mode is mailbox. Sick. Set the desired extent and the desired minimum image count and usage flags. Cool. And here it's getting the swap chain images. Cool. It's creating a command pool with the reset and with the graphics queue. Cool. And here it's creating some frame data. Now for each frame, it's creating a semaphore, acquire semaphore, render semaphore, present semaphore. Then it's creating the fence, another fence here. Allocating command buffers. And then it's making a get proc function, which takes in a name, an instance, and a device. And it returns some function. If device not equal to return, vacate get device proc ADDR. Okay, so this is the biggest error it's doing. Not error. I mean, as you can see, it's working. But not the best way to go about it. Because the thing is here, vacate bootstrap is actually loading the Vulkan functions into our dispatch table, but it's not using them. It's just using directly the static loader. So that's the biggest error, which is fine to some degree. It just decreased performance, that's all, mostly. Anyways, return vacate get instance proc ADDR instance name. Cool, alright, fine. Next up, finally, we're getting into Skia stuff now. So we're creating a Vulkan backend context, and then we're setting the instance from the instance that we got from VK Bootstrap. We're setting the physical device, the device queue, graphics queue, the graphics queue index, and max API version, and get proc and protected context. I'm not sure what this protected context is, but whichever. Is the data protected on GPU or not? Okay. And the memory allocator, here we're just using this Vulkan memory allocators thing. Make the wait. This seems to be from private header, so I'm not sure if that's supposed to be used, but who cares anyways. Let's go to the next thing. So here we're using Graphite backend context options, and we're making Vulkan. We're passing it the Vulkan backend here, and the context options, which seems to be empty here. And then we're creating a recorder from this Graphite context. What is this? It doesn't really say, but we'll see what is that in a second. And the extent, the swap chain extent, cool. The frame index and the quit. Now, obviously, we're pulling the events, and if we get a quit event, then we're just quitting. And here we're getting the current frame using this frame index that increases every frame, obviously. And here we're waiting for the fences. We're waiting for the fence and the present fence. I don't know about that because I've never used that present fence extension, but okay. But seems good so far. Reset the fences and reset. Okay. Now we acquire the next image using the swap chain, the device. Swap chain out of date, not handled yet. Cool. Acquire next image. And finally we get our current swap chain image. And let's see what we're doing here. So we're creating this Vulkan texture info from Graphite. Alright. And then 0 alloc. What is this? Times for interaction with Vulkan. So Graphite backend textures make Vulkan. Extend.width, extend.height, text info. And then finally wrap backend texture. So wraps a GPU back texture in an SK surface depending on the backend GPU API. The color may be required to ensure the texture is valid for the lifetime of the returned SK surface. The required lifetime for the specific APIs are metal. Skia will call retain on the underlying MTL texture. So the color can drop it once this color returns. SK surface is returned if all parameters are valid. The backend texture is valid if its format and dimensions supported by the context that created the recorder. The color type reported by the SK surface image is inferred from backend texture format. This is fine as the. Okay, so nothing fancy for now. Anyways, so basically we're just wrapping the image into an SK surface. Though I'm not sure if it's a good idea to like wrap the image every single frame. In my view, at least, I think so, that you have to like wrap it once and then just save that. But we'll see about that. Recorder again. And here we're using the recorder for whichever reason. Okay. And we're passing it the backend texture. The color space, make sRGB, and the properties. Okay. Anyways, let's go to the next thing. And finally, we're getting our canvas from the surface. And yeah, notice we didn't really need a dynamic render or anything. We're actually using the Skia to render stuff, so we don't even need that stuff. Yeah. Okay, I actually kind of forgot about that, but anyways. So if the surface canvas clear with white color, and then here we got some center X, center Y, and so basically the center of the screen and in the X and Y, and a radius of the minimum between the width and the height. Okay, divided by 3. So basically to keep the aspect ratio, and we create a paint object. I'm not sure how heavy are these paint objects, or like are you supposed to cache them, or what exactly, but we'll see about that too. And set set color canvas, draw a circle. Sick. Set style, set stroke width, set color, draw a circle. Recorder.snap. I'm not sure what this snap is, but I would guess to basically like finish the recording of the render commands, I would guess. And then we get a wait semaphore, and we make a Vulkan backend semaphore. Okay, and here we got like an insert recording info. This is interesting. I don't know what the heck they're doing here. So recording.get, and then it takes in the semaphore that we made, signal semaphore, and then we insert recording. Okay, and then we submit. Okay, so we're using the Skia context to submit stuff. Alright, so that's why we need to give it we need to first of all wrap them in the backend semaphore thing, and then we need to give them here. Alright, so I do have a lot of questions, but so far seems fine. Oh, so then it's actually starting beginning a second command buffer for whichever transition this is. Alright, so the barrier is the color attachment right bit. Yeah. Alright, so right here is just basically transitioning, or like the image layout of the swap chain images from color attachment right, which is basically what was needed for the for Skia, and to the present layout, so we could present those images essentially. Okay, and the command buffer, and wait for all the stages. Fine. And then we submit. Cool. And here we got this present fence info thing. Present fence. VKQ present. Sick. And then vacate device. Wait, what? What do you mean vacate device we idle here, bro? Oh, is it like the end of the loop? I think it's probably, oh yeah, never mind. So it's just the end of the loop, so that's fine. Backend context memory allocator dot reset. Okay, device way idle, and then we go through all the frames, and then we basically free the resources. And yeah, honestly, perfect job. As I said, the only thing that I've noticed that is terribly wrong is just that it didn't use the dispatch table, but we could actually tell it that, so that's sick. But before that, did it like commit the changes? No, it didn't. So first of all, commit changes, then, or should we try to question it and see what it's gonna say first? Yeah, let's go to the plan mode and let's question it. Why you used the loiter functions instead of the vk bootstrap dispatch tables. Let's see what it's gonna say. If it's gonna catch the error or not. So that's honestly the only thing that I've noticed that is terribly wrong. Yeah. The other thing seems perfectly fine. Really? No. No, 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 no. No, it's just terribly, nah, it's just not getting it. No, you should use the dispatch table. I mistakenly, typo, but whatever. Let's see what it's gonna say. Yeah, the only error that I found, I'm gonna. Oh, well, yeah. Anyways, play mode. Okay, so right now it's gonna go ahead and research about how it's gonna use the dispatch tables. So that's sick. And it's gonna take a little while, I guess. But so far, so good. I mean, even if we were to rewrite this whole thing, we have a very great prototype to start off from. I mean, honestly, just like the the Skia and CMake setup alone is enough to to help us start off. But yeah. Alright, let's see what the heck it's talking about here. I'm not sure what the heck it's talking about here, bro. There you go. Finally, it catched it. This avoids Vocaloid trampoline overhead for every direct call we make. Boom. I don't think, I mean, it could just grab that function maybe from the dispatch table, though I'm not sure. We'll see. But at least fix this one. Commit the current changes first. Then use the dispatch tables. There you go. And it works. Now let's actually ask it, eliminating the trampoline, how much performance you saved? Actually, can it like, I don't know if it could like do benchmarks for us. It's not a big deal, you know, but still, it would be cool to know. So FK Pro captures, so right now I'm on plan mode again, and let's just ask it a couple of questions here. Negligible, huh? About 1.5 nanoseconds. 2 microseconds per second. Really? Result once and in a guaranteed valid, no runtime loader surprises. Weird. I don't know. Whichever. Maybe it's covering itself up. I don't know. But anyways, idiomatic Vulkan practice spec says to use for anything beyond trivial usage. There you go. Avoid PLT deal for Skia FK Pro wouldn't matter in practice, but it's the right way to write Vulkan code. Alright, so we fixed that one. Okay, so what we're gonna do next? So should we try now to include yoga into the mix, or actually we should first of all make I don't think it's making the in-flight fences just in-flight frame, or is it? I don't think. That's the first thing. The second thing is the resizing. It needs to handle the resizing. So I think I should probably start with the resizing first. Then we'll go into the other one. Okay, so, or actually let's ask it what it's gonna do next. So now what's next? Let's see what the agent would suggest itself, instead of, you know, running to conclusions here. Dear MGY, hell no way. We already have Skia. Why the heck would you need MGY? Anyways. Refactor our monolith main. Nah, not really, I think. Not yet. No need for refactoring just yet. Texture loading animation, multiple flash, not the demo contract. I don't know about that. Anyways, let's go with the swap chain resize handling, sure. Swap chain resize handling. But wait, actually before that, let me ask you about the in-flight fences. Or in-flight frames or whichever. I need a coffee at this point. Really need a coffee. The current fence model. Yeah. So now that we got the present fence, we no longer need the regular fence, I guess. Which is strictly after which signals. We only need F present fence to know both the transition command buffer and the semaphore are safe to reuse. Cool. Frame count versus swap chain. Really have all 3 slots occupied. Could drop to 2 without stalling. What's your angle? My angle. I don't really have a particular. I think let's leave it to implement first of all the resize. Implement the resizing first. The robust resizing and swap chain recreation. And then we'll talk about the in-flight fences. And at that point, I think I'll maybe end the stream until tomorrow or something, I think. Yeah. Or is it? I mean, we could probably have some time for yoga, but nah. So just finish up the core app, which is basically just proper in-flight frames and proper swap chain recreation and resize, and we should be done with the core app where you just kind of like some Skia rendering with some good core application. And tomorrow we could add the layout engine maybe. And also I'd love to also use SDL main callbacks, that too. And after that I think I'll just end the stream until later on. I don't see any resizing happening, so I'm not sure what the heck it's talking about. Or maybe it's using some X11 tools to do that and it's not working out for it. Probably, but yeah, X2 tool. I don't know, but yeah, let's just check it out now ourselves. Actually, I can't even resize it. It forgot the event resize thing. But did it at least like recreate the swap chain though? I don't know. Let's see. Actually, it shouldn't be that hard though, because like yeah, there you go. Recreate swap chain. Shouldn't be that hard because we're using VK Bootstrap. So that's something. So I'm gonna just honestly tell it so it doesn't lose track of the context. Just make sure the window is actually resizable through SDL. I could have told it that Xdo tool probably doesn't work for Wayland, but whatever, anyways, who cares? I could have easily added that myself, but I didn't want to interfere. Okay, works perfectly, flawlessly. Nice, lovely. All right, so let's go to the next thing, which is, well, let's actually do it in planning. Now implement in-flight fences. Remove empty fence, pass as a fence in the transition queue, submit. Okay, so I think that fence is now redundant since we are using the present fence extension, I think. I'm not sure, but yeah. Not in-flight fence. Honestly, you know what? Let's call this in-flight frames because it might be misinterpreting me there. Because I don't think the current setup is actually using in-flight frames. I think it's just sequential. Because we're waiting for a present fence, but yeah. Oh, okay. Yeah, so actually it already does apparently, okay. So apparently it is already in-flight fences. Though we could consolidate one fence per frame. Three, and tell me more about four. Because I don't know what that present wait thing is about. And that maintenance one too, on device wait idle. Wait, would that remove the fences or what? I'm confused. That looks insane. Oh, really? Bro. So we could just remove the fences. I mean, that's what I understood. I just want to confirm. But yeah, if that's the case, that's lovely. Cause oh my god, like that, those in-flight frames were confusing me for a long time. Exactly. So it's kind of like semaphore. No, I mean timeline. Timeline fences or like timeline semaphores. Yeah. But for the swap chain. If present ID greater than or equal to max frames, then we wait for the present. I mean, heck yeah. Okay, do it. Just do it. Let's see if it's gonna work. So we're gonna remove the fences, we're gonna remove the wait for fences, we're gonna remove the reset fences. Yeah, that would be sick if it works. I don't know. Or definitely could be hallucinating, though I don't think so. Seems perfectly logical. So yeah. Right. Seems logically. Whoops, I've closed it by accident. Should have not done that. So I removed 8 fences and 4 wait reset calls. Bro, this is insane. And no validation layer errors. This is magic, bro. Magic. So we removed all the fences. Right. Okay. That's a cool extension right there. So let's go back to plan mode. Any other swap chain extension tricks? That was amazing. Let's see. I always love new Vulkan extensions. Because oh my god, like the first version of Vulkan without extensions was a hell. But like with every single extension they were like simplifying more and more. Which is perfect. Though I do remember that it said that it doesn't need device wait idle anymore. I think. I don't know. Alright, so let's see what's up here. Glad you like it. Here are the other notable ones I'd consider. Get swap chain status. Proactive out of date check before acquire. Avoids the wasted vacate acquire next image route trip on a stale swap chain. Okay. In the maintenance extension. Chain to force the driver to scalably the swap chain, render a half resolution driver. Useful for performance time without recreating. I see. So that's kind of like maybe for full screen or something. Anyways. HDR output. Let you set the display's color volume metadata and use the extended color space via. If you want HDR but adds complexity, tone mapping, color management. I think that you could only use that if you have like a HDR monitor, though I'm not sure. I mean, let me just check that. And then there is the Google display timing. Frame pacing gives you for first cycle duration Google. I don't really understand, but maybe I could research it more like off camera. But anyways, shared presentable image, 0 latency. Oh, so this is like about Wayland. I see. So like yeah. So like in Wayland, there's like this kind of direct scan out instead of having to go through the compositor. But it's only possible if you have like a specific format, etc. And I think that's probably the case here. And you basically get 0 presentation because like your application renders directly into the frame buffer of the screen of the monitor, without having to go through the what is it called even? The compositor, right? The desktop compositor. Yeah. But add steering unless you double buffer with it. But if you do it, you gotta actually double buffer yourself then, which is interesting. But anyways. Yeah, I think that git swap chain status thing is nice. Not a big deal, but nice nonetheless. And I'm curious about the HDR thing. The shared presentable image is interesting, but probably an overkill for my use case, at least for now. I don't know. Yeah, there you go. Yeah, so I don't have an HDR monitor, so I can't really help with that. Yeah, I think we're done here. Right. The only thing though is that it said before that it could dodge that device way idle. I'm not sure if it just forgot. Sure, who cares? So I'm gonna tell it to git commit first. Then implement the release swap chain images KHR. And what else? What is the other one? Yeah, the swap chain status thing too. Not a big deal, but perfectly cool. And git swap chain status thing too. Anything I missed? I don't think. Yeah, so, and I think I'll probably just stop the stream at this point. That was an amazing adventure. Didn't start off well with the Skia and CMake VS, but with the agent kind of saved the day. And let me know if you want to see more of these streams. Uh-oh, I think we got like a dumped segfault there? Yeah. I'm not sure why. Why it's searching for presentable image? Weird. Oh, GDB. Okay, so there you go. It's running GDB. Is null. Okay. All right, so it needs that extension. Shared presentable image. And boom, it works. That's just amazing, man. Clean. So the final thing I think I'll do is just implement the SDL3 main callbacks, and I think we'll end the stream. Commit the current changes first, then implement SDL3 main callbacks, and commit. Oh no, let's just do this only. It's committing, right? Just to make sure, I'm kind of paranoid there. Yeah, it does. Yeah, there you go. That's sick. And with that, we should be done. Permission required. I don't care, fine, go ahead. I should honestly add SDL3 as a submodule. Let me write the restructured file, preparing write. I wonder if it's going to use like global variables, or it's going to use like a whole global struct that it's going to be allocated. It should do the latter, and I think it probably did do the latter. But you gotta find reference because it probably have forgot the SDL3 main callbacks macro. Yeah, probably. Because it's saying the find reference to main. Because it's, yeah. It should also include like the SDL main header. But whichever. There you go. Here, find the documentation. Sick. And there we go, the compaction, because it reached 70% of the context window. So it's gonna run that compaction thing again, where it basically kind of like compact the whole context window down to yeah. And yeah, that was cool. That was cool. Right now we use Skia with Vulkan 1.4 with all the cool like the presentation extensions, and with VK Bootstrap, which really ended up simplifying a lot of things too. Yeah, cool. Love that. Really love that. And we have wrote not even a single line of code. We have just directed the agent, and we have spent $0 too. So yeah, but you know, the next time I'll get my paycheck from YouTube, I'll definitely buy some credits and then we can go wild with some cool model. Feel free to donate the comments, like using thanks, thanks comments or whatever. But anyways, for now we're good to go. Apps run clean, fixed, need include explicitly, it's not included. Okay, and include, required explicitly. All right, so I think it's pretty much done. Let's try to run this and let's see what it did there. And there you go, it added SDL menus callbacks, which is perfect. And there's no validation errors either. And everything looking great. Great. Okay, so where are the callbacks exactly? There you go, SDL app init. And what's the, yeah, there you go. So you've made this app state struct. Yeah, it put it everything in there. Actually, it was already there, I think. Maybe. Yeah, I'm not sure, but anyways. So as you can see, it's allocating it. And yeah, cool. Cool. And finally, in the app event, you're just doing this. In the app iterate, it's casting the thing here. And yeah, perfection. I'm gonna ask it one little question before we go, which is about this graphite backend texture wrapper thing. Yeah, wrap backend texture. Is wrap backend texture, is Skia wrap backend texture meant to be done every frame? I mean, it could be just like a little lightweight wrapper just for the framework thing, or I don't know, like for the intro. Pre-create one per swap chain via wrap, just require index switch. Can you check if it really allocates, or like what wrap backend texture does? Read the source code. That's something you could do. And let's see what it really does. Is it like really a lightweight thing? Or, I mean, it did say here that it does allocate GPU resources, which means hell nah, that sucks. But let's see what's gonna happen here, because I'm not sure honestly what that maps to exactly. That would be really useful. There you go. It validates the backend texture, calls create wrap texture, creates a texture proxy, create a device with what? So just heap allocations, image view creation. Alright, so I guess maybe let's add this last. Is there any other ones like that we want to also ask about? There's also the, what is it called? The Vulkan analog stuff. No, wait. No, not that. I meant the paint objects, for example. And this backend semaphore stuff. How about the paint objects, the backend semaphores, and other stuff? And wait, it's not using the synchronization 2 here, but honestly I think, yeah, so it's already 4 hours, so yeah, I think I'll just probably stop here really at this point. So yeah, thank you guys all for watching, and see you in the next one. Goodbye everyone.